Okay, on this example, we're told that f and g are both differentiable functions. We're given some information about f at 2, g at 2, f prime at 2, and g prime at 2. And we're also told about this function h of x that's defined to be in terms of f and g of x. And we're asked to do a little bit of computation here where we want to find h of 2. Well, that basically boils down to fill in a 2 for each of the x's on the right-hand side or evaluate each function at 2. So that's going to be 3 multiplied by f of 2, plugged in the 2 for the x there, minus 4 multiplied by g of 2. From here, we really just need to fill in the information that's given to us up above about f of 2 and g of 2 using the correct values from the right-hand side. So h of 2 is going to be 3 multiplied by, instead of f of 2, we can replace that with 5, minus 4, and then instead of g of 2, we can replace that with negative 3. So h of 2, a little bit of simplifying on the right-hand side, we get 15, and then negative 4 times negative 3 is going to be a positive 12. Add these together, and we get 27. All right, so h of 2 equals 27. The next thing we need to do is compute what is h prime of 2. What this boils down to is we're going to take the derivative of each function on the right-hand side as we go. It's going to be 3 multiplied by f prime of 2 minus 4 multiplied by g prime of 2. Note 2 gets plugged in for each of the x's on the right-hand side, but because we're doing the derivative, we're taking the derivative of each function on the right-hand side as well. So this is going to correspond with these values that have been given to us about the derivatives. So h prime of 2 is going to be 3 multiplied by negative 1/2, gets filled in for f prime of 2, minus 4 multiplied by 2, which is g prime of 2. A little bit of simplifying down here. We're going to get h prime of 2 is going to correspond with, well, 3 times negative 1/2 is going to be negative 3/2 or negative 1.5. And then negative 4 times positive 2 makes negative 8. So as we combine these together, we're going to get negative 9.5. All right, so that takes care of part A. In part B, we're asked about this tangent line to our curve h of x at this point 2 comma h of 2. So to get that, what we're going to do is use that information we found in part A. Basically, we already found what h of 2 was. So we have this ordered pair 2 comma 27. Right, that corresponds with that h of 2 we already figured out. And then we also need the slope of our line. Well, the slope of our line is going to correspond with the derivative of our function at that value of 2. So in our case, negative 9.5. So we have these two pieces of information we gathered from the first part. We just kind of had to interpret that that derivative means the same thing as the slope of our tangent line. From here, what we want to do is we want to find this equation of the line. Well, it's going to be y equals mx plus b. That's the easiest one for most students to remember. We have an x value, we have a y value, and we have a value for m. So let's kind of fill in each of those pieces of information. We're going to fill in 27 for a y. We're going to fill in negative 9.5 for our m. And we're going to fill in positive 2 for our x value. Now we still don't know what b is. We're going to do a little bit of solving down here in a second to find b. All right, so the first computation I'm going to go ahead and do is figure out negative 9.5 times 2 is negative 19. And then to finish this up, we simply need to add that 19 to the other side and go 27 plus 19 is going to give us 46 for our value of b. Let's go ahead and fill that back in up here at the beginning. All right, so our equation is going to be y equals, we're going to keep the slope the same, negative 9.5, keep x as our variable, and then it's going to be plus 46 for our value for b that goes at the end. So when we get done, this is the equation of our tangent line for any x value, preferably really close to 2 because that's the point we utilize there for our tangent line approximation. All right, hope this helps out as you're working on understanding functions that are defined to be based on other functions and the given information. Good luck.